Welcome to the last episode of this series. We are building a Mint NFT application, and today's episode, what we're going to do is to integrate our smart contract in the interface. To achieve this purpose, we will use ReactHook Library. The name of the library is we are going to make it. And this ReactHook library includes React hooks, to basically create all the things that we need in a Web3 application. We can use account, use network, contracts, signers. So all the things that we need to basically build a Web3 application is provided in this library, and that's the library we want to use. This library, as you can see in the starter, it needs ethers as a dependency. So that's what we're going to do in our project. We will install, we are going to make it and ethers. There you go. Now, to be able to deploy, if you remember from last episode, if we want to deploy our smart contract, we will need the smart contract code, like the compilation of our smart contract. And from last project, the MintNFT contract, we call our contract MintNFT. So I will copy that contract into this project folder. So I know I have my contract in the MintNFT contract. That will be on the artifacts and MintNFT contracts, MintNFT, and in here we will have a JSON file that has our contract. Now this file is a JSON file. We will need to import this file into our project, and that's why I will put this file into the source folder. So now we have our contract in the project. The next step is to proceed to the Mint, but one part of the Mint is that we need to provide a visual clue or a visual indication of the things that are happening right in our application. We will have to specify what network are we currently on. We'll need to specify the wallet that we are connected to. So these are small things that we need to change on our UI, and we will be implementing them as well in this part of the project. The first UI modification that we will do is on the image upload input. In that input, we will add one more property. We will call that property read only, and it will be a Boolean. That property will limit the functionality of the drop zone. So in the drop zone, we will also set the properties for multiple false. We will set that only accepts images, and we will disable if it's in read-only mode. And the other thing that we will do is don't or disable or not show the remove image button. So this will only be shown if it's not read-only. And there you go. That's our component. Oh, right, it's read-only. There you go. That's the fix. So this component now takes the value, the unchanged and read only. And this read only, once we mint the collection, it will be set to read only, so we cannot modify the images. Next, we will add 3 icons to our interface that will represent the icons for the wallets, the type of wallets that we want to use in our application. That will be MetaMask, Coinbase, and I think it's Wallet Connect. So what I did in this case is I searched for the SVG format of these icons, and you can take these SVGs and put it in a React to SVG or SVG to React conversion, and then you can have a React component that wraps the SVG image. I already have those images here, so I will just create the components using the image. You can find this code and copy it from them. So wallet link icon will be one of them. This is the code. You can see it's a React component that basically wraps an SVG image. We will create also another icon for the Wallet Connect. And we will create one last icon for MetaMask. There you go. These icons will be displayed next to the, when we connect to the wallet. We will have like a model that will show up on the screen with 3 options, and each option will have its own icon. So MetaMask, Coinbase, and Wallet Connect. Wallet link, sorry. The next component that we're going to build, this is a new component, is the model itself. So this model, we will open it when we click. So we will change the UI to put a connect your wallet button. And when you click on the button, it will show a model with the possible wallet connections that we can make. We will show MetaMask, we will show Wallet Connect, and we will show Coinbase. And we need to build that component because we don't have that component yet. So for that, let's create one new component. Let's call this component Wallet Options Model. And let's create the interface for this. No, it's not image. It's wallet options model props. We don't know yet what properties we need, but just put it there. Oh, we need to return something here. Now, this will return a model, right? So a model is we can find it in the documentation. A model is a chakra component to basically create models. Models are this window that we can show on the screen that has some interactivity or information like this. So we will have a model that will show buttons for the wallets, and if you click one of the buttons, it will connect using that wallet. By the way, this functionality of connecting to the wallet is something that we're going to make it library is provided. But in this case, we're using the model from the UI. We're using the model from Chakra. So we need to use a model component. That model component has an isOpen property, and let's call this property isOpen, and the other property is onClose. So I think these two should be properties of the isOpen and onClose. Now, inside a model, we will put the model overlay and the model content. Inside the model content, we will put a header. That header will say connect your wallet. We have a model close button, and you have a model body. Inside the body, we will put the buttons. Now, for setting the buttons, we're going to make a library. We haven't configured yet, but that library has a set of connectors that we can use. You can connect to different sources. For now, the connectors, we will configure that later. But we can use a hook from the we're going to make a library to basically get access to those connectors, and those connectors are the ones that will allow us to connect to the wallets. So let's do this. Let's use the hook, and the hook name is useConnect. We need to import useConnect from we all going to make. That useConnect, as you can see here, will give me information about it will give me information, data, error, and loading. And data will have an array of connectors. So that's the one that I need. And this comes in an array. So I will get the first element, data, connect data. Now with that connect data, we can create a mapping, connect data dot connectors dot map, and for each connector we will render the button. So a box, that box of course has to have a key. Need to import the box, and inside that box we will put a button, not this button, this button is a tracker button, and inside that button we will put an expression saying the connector name and another expression saying the other expression saying if connector not ready, let's put support. Otherwise, just an empty string. Okay. So that's our map, or like that's our list of buttons with all the connectors. By the way, that documentation, you can find it in online. Basically, there is a repository on how to integrate Nextjs application, and we are going to make it a library. And basically, I took the code from that repository. I will share the repository with you in the description. Now, these buttons, well, these boxes, let's change some properties here. One is display, should be flex. The other property that we're going to change is the flex direction, should be column. And we will put a margin button of 3. So every button is a little bit separated between them. Now, the connectors button, first, if it's loading, so we can get that from here, loading. If disable, if the connector not ready, so if the connector is not ready, we will disable that button. If we do on click, so on click on that button will trigger something that we don't know yet what to do. So it's cool. And we need to put the icon. So left icon, and here we will put, let's put a wallet logo component. This wallet logo component doesn't exist yet, but we will create this. And in here we will put the connector ID. So we will use the connector ID as a way to identify what logo we will put in that position. Now, wallet logo is not created there. That's our next step. We will create this component as well. The wallet logo component, logo.tsx. This is a very simple component. It's just taking that logo property and rendering one of the 3 icons that we have. So let's do that. From React interface. Okay, so it could be one of 3 choices. So if the logo is wallet connect, so if the connector has ID, right? For wallet connect, it will be wallet connect. For wallet link will be wallet link, and for MetaMask will be injected. So those are the logos or the IDs that we are expecting. So if it's wallet connect, we will return the wallet connect icon. Now that icon, we will add some width and height. So it will be 32 pixels. The second logo is the logo for wallet link. In that case, we return the wallet link icon. And if it's injected, that's the ID of the MetaMask connector, then we will return MetaMask icon. If it's none of these icons, then we can just return null. Nothing will be rendered on the screen. So now we have our wallet logo component. One more thing that we need in our component is in the body, we will try to show if we have errors. And for that, we can use the error, property of the use connect. So we can call here error. And here we will say, well, if you have errors, what can we draw here? Let's use the alerts from Chakra. So Chakra has an alert component. Here's the component. We can copy paste this. And let's use that on our now it has an alert icon. Well, we need to import all these components. Alert title. Well, the alert here is that there's an error. And here we can just show the actual error. So if we have an error, we can do message or fail to connect. Description. Close button. We don't need a close button for this, so let's remove that. That's our error alert. And we also need a footer in our model component. So let's do a model footer. In that footer, yes, exactly, we need a close button. So let's do that. And we need to close this. That's our button. To close, and this is our alert to show if we have any errors in the connection to the wallets. We miss in the button for the wallet, for each wallet, what is actually going to do this button. So in this case, once the user click on the wallet that he wants to connect to, we miss the action. Now for that we need a method connect that comes in the use connect hook. That method allows to force the connection of a wallet, and that's what we're going to do here. We will connect using the connector ID. Actually, the parameter is the connector, not the connector ID. That's our onClick function. So technically, our wallet will be connected, but once we connect to the wallet, we need to close the dialog, right? The model. And we can check that change if we get access to the wallet, right? So if we get access to the account that is connected. So for that, we will use the use account hook. And for that, we will use cons data, account data, and we will use the use account hook. So this account data, because it's a hook, it will be listening for that change. So as soon as we connect to a wallet, we will have the wallet connected. So in here, we can do a hook, an effect hook, that listens for that change and basically says, well, if we have an account data, we can do on close. And this is our wallet options model. We only have to pass an open property and a closed property. And it will show all the buttons for the wallets that we have configured. That's the next step. Configure the library. We are going to make a library with all the connectors that we need. This is a component. Now, to configure we are going to make a library. We need to do that on the app page. This app page is the one that, for now, just have the chakra provider, but this is the one that will have the provider. We are going to make a provider. So we are going to make it contains a provider component. That provider component, you can use it to wrap all the components that you want that has access to that, that will have access to the hooks, right? In a Nextjs application, the best place to put this is in the app component. That's why I'm adding this here. So we are going to make it. Along with the provider component, we will also import chain. These are some helper functions and default chains. Also, we need to import some of the connectors. So let's import the injected connector. And we will import that from, we are going to make it /connector/inject. We're also going to import the wallet connector. Wallet connector, yes, this is the exact code that we want. GitHub Copilot is doing an amazing job here. Wallet link connector, that's exactly what we do. So these are the imports that we need from We Are Going to Make It, and now we can create the types for the connectors. So type connector will be any of these types. Okay, the next step is to wrap our application with the provider, we're going to make a provider. And that provider, you can pass some properties. One of the properties that we're going to use is auto connect. So when you refresh your application, if your application is already connected, so it will automatically connect again. And the other parameter is connectors. These connectors is basically a function that will return all the connectors that we will use to link our wallets. So connectors, it will be a function. We will declare this function next. So this is the provider. Now let's create a connectors function. The connectors function connectors is a function where we're going to pass, according to the documentation, we're going to pass a chain ID parameter. This parameter is optional, and we will return an array of connectors. Let's return an empty array initially, so everything looks good. And let's try to create what connectors are we going to use. The first connector that we will add is the MetaMask connector. That's the injected connector. And the parameter for the injected connector is the chains. And for that, we will use the default chains that we're going to make it already provides. Next, we will create another connector, and that will be the Wallet Connect connector. Wallet Connect has its own properties. Oh, Wallet Connect and Link Connect. Now, Wallet Connect has its own properties. It's not chain ID. Not sure why GitHub compiler is auto-completing that. But we have its options. And in the options, we need to specify an Infura ID. We will learn what Infura is right now. For now, let's leave it empty. And a QR code. So QR code true. That means that it will use a QR code to be able to connect to a wallet, usually mobile wallets. In terms of wallet link connection, the options are the app name, in our case is MintNFT, and we also will have a JSON RPC URL. Now, JSON RPC URL also depends on Infura, so we will have to create an Infura application, and you will learn what Infura is. So in here we will have an RPC URL property that we haven't calculated yet, slash Infura ID. So let's see what this Infura ID is. Let's create here Infura ID. Let's create the Infura ID. We're going to make it chips with some connectors. They use Infura's API services to be able to pull information from the blockchain, especially Ethereum. And if you want to connect, you want to use those connectors, you need an Infura application. So to that, you basically sign up for Infura. They have a free trial that you can use for your services. And if you need a bigger, you need more access to requests per second, or you need access to other extensions like other networks, etc., then you can pay for the services or pay for add-ons or plugins. I already have an account with Infura for this project, so I was just logging in my account, and you can create the projects. This is the panel. You can create your projects. In the project, you select what type of network you want to access: Filecoin, IPFS, Ethereum 2, or Ethereum, and you set a project name. And once you have the project name, then you can open your project, and you can see, how many requests or all the activity on your project. Now, on the settings, on the project settings, you can find your project secrets. So the secrets, you can configure your access to your project, because remember, this will allow you to access from the front end, but also from the back end. So if you want to make some automations in your Web3 applications, you can do it with Infura as well. I will not be opening this page because the secrets are just visible in the page. That's kind of like a bad design. From then, I think they should at least hide them. But from that page, you can get your Infura ID, right? It's a per application Infura ID, and with that, then you can configure the connectors for Infura. So I will copy that. In our Nextjs application, you can put it on the .m file using the next public prefix. So it will be accessible on the front end. Remember, this is something that we would use on the front end to connect to wallets using Infura's API or Infura connectors. So let me put this in the other screen. And from the project settings, you can get your project ID, and you can create a .m file with your project ID, right? So Infura ID equals process.m next. public. Okay. Now this RPC URL parameter here depends on the chain ID that we are passing in the connectors function. This is a callback that they provided. We are going to make a callback is passing. So we have to assume that in this chain ID will get a chain ID. So for getting the RPC, we'll do a small function to find the RPC URL. So RPC URL. And for that, we will use the default chains, and we will find in that default chain one chain whose ID is similar to the chain ID that we're looking for. Now, if we got a result from this search, we can get the RPC URL. It said that this is RPC URLs. Oops. And if we get a list of RPC URLs, then we can get the first element in that URL. If we don't get the result, we will specify another value, and for that we will use chain dot mainnet dot RPC URLs at 0, and that will be the value of RPC URL. Chain is another thing that we imported from We Are Going to Make It, and default chains are the list of chains. So we are trying to find the chain with that ID, and from that chain we are getting the RPC URLs. Okay, so those are our connectors, right? And that's the function connectors. At this point, our application is already configured to be able to access the Web3 hooks that We Are Going to Make It provides. The other component that we will going to modify is the top bar, right? So for now, the top bar looks like this. We can run our application and you will see that the top bar looks like this, just a mint. And it has a progress bar here. Like when we upload the images, it will show a progress bar. So what we're going to add to this top bar is a button on the right that allows us to connect to a wallet. So let's add that in the top bar component. So in the top bar component, we will add, after that progress bar, we will add another box that will contain a button to connect to the wallet. Let's make a small button. And on click, this button will set a state is wallet model open. The button will say connect wallet. That's our button. Of course, we don't have this state, so we need to set it up in our component. Is wallet model open, and by default is false. Now we have the button, and now we need the actual wallet. So after the box, let's put the wallet options model, and it's open. And when we want to close it, we say set is wallet model open false. I guess we need to import this component. And there you go. So right now, our top bar has a button to connect the wallet and the model that will show that wallet connection. Let's see. When we connect the wallet, we will see this dialog. And in this dialog, we have MetaMask, Wallet Connect, Coinbase Wallet. You can try to connect with any of those. Even with MetaMask. So you get the MetaMask and it will ask you to connect to that. Now, if we connect to the wallet, we should have the opportunity, to disconnect from the wallet. So I will be connecting this wallet that I have. And as you can see, the button itself doesn't change state. So it still says connect to wallet. So we need to basically change that button for that button to disconnect, right? So let's do that. To be able to achieve that, we need to get the account. So we need to get the account. For that, we have a hook, use account. So we can say account, use account. We are going to make a hook. Now, inside account, you can see that the response is a data that has a connector, the address is a string, and if we have an ends, like an Ethereum name service, so this Web3 hook also pulls the information from the Ethereum name service. So let's try to get some of that data. So we have the data. This will be the account data. And the other thing that we get from the hook is a disconnect function. So we can use the disconnect function to actually basically force a disconnection on that account, right? And if we have an account data, that means that we are connected, so we can show the button. So in here, we will have two buttons. So if we have an account data, we will show one version of the button. That will show disconnect. And otherwise, we will show the connect wallet version. Now, the version to disconnect will do on click, and it will run the disconnect function. Let's make this button similar. And another thing that we can do is that just to show the user that we are actually using the right information, sometimes people like to show a partial of the address. Let's check it out now. So right there, this is our button. It says disconnect. Now, we disconnect. It's disconnected. If we try to connect again, it will ask you to connect the account. Once the mint is completed, we will disable this interface almost completely. Instead of showing a button, we will show like a success message. Your collection was minted, your NFT collection was minted. And we should also provide a button to restart or start a new NFT collection. So let's modify the properties for the top bar to be able to provide some indication that this this NFT collection was minted. So we can change the interface and show a reset button, right? So one piece of information that we can use for that is the contract address. So one contract address. The contract address will be a string, and that means that if we have a contract address, that means that the NFT collection was minted. That's why we have a contract address, and we will have to add a new collection. So so we can basically support a click on some new button that basically resets the whole form. So contract address and on new collection. Now, if we have let's add some margin here and some height, because the thing with this is that if we change the content, of this top bar, depending on the new height of the content, our whole interface will shift in position, right? And that's actually not a good experience. So that's why I'm giving it a high. So I know it's a very decent high. Everything will be inside that container, and if the content changes, nothing below the container shifts in position, right? So it gives a better experience from that point of view. Now, we need to add the min button. Needs to be modified because right now it's not always mint. So we will do this. If we have a contract address, we will show a different experience. Otherwise, we will show the min button. And that different experience, let's put a box around it. That different experience will basically have a text from Chakra. Let's use text font size. Let's give it a bigger size, 2XL. And that text will say NFT collection mint. And below that text, we'll put a button with a very small size, different variant. And when we click on the button, it will call the on new collection function. So start, create a new NFT collection. So that's the change that we want to make. So if we have a contract address, means we already minted the previous collection, we will show new collection minted, big text, and below that we will put a button to say create a new collection. The last component UI that we have to change is the NFT element component. Remember, this is an input, a control component, value on chain, remember. And this component, we need to make some changes in this component because we want to, one, disable this component when the collection is minted. We don't want more changes to the data. So this component will need some type of indication that the collection was already minted. For that, we will use the contract address. The other thing is that for each contract, each NFT inside that collection, the ID of the NFT is a number starting by 0, so 0, 1, etc. But the NFT element component by itself doesn't know what position in that collection that NFT has. So we need to add here the contract address, and we need to add an index as a number. So the NFT element knows what position they have in the collection, right? So contract address will help us disable the elements, the read-only elements, and the index will allow us to once the collection is minted, we would like to show a link to the OpenSea element a link to the OpenSea element. For that, OpenSea, the other important thing is that OpenSea has also a testnet, and that's the net that we will be using. So that it will be also important or necessary to specify if we are deploying this contract, this NFT contract in a test network. So let's add another property, is testnet. Why is testnet necessary? Is because if we are making a link to OpenSea, the URL in the OpenSea for the testnet is different. So we want to identify if this is a collection or NFT element that was deployed on a testnet, so we can change the URL and include testnet in the URL, right? That's the way OpenSea changes from the main network to the test network. So we have contract address, index, and testnet. So the first thing that we will do is disable the delete button. So no more delete button once it's minted. We don't need the delete button. So we only show the delete button if we don't have a contract. Right? Now, the other important thing, and this property we already added to the image upload input, is the read-only. So now we have a read-only property. And of course, the read-only is a Boolean, so we can say if we don't have a contract address, that will be read-only. Sorry, if we have a contract address, that will be read-only. And we also need to put read-only on the input. So for the name, read-only, same thing. For the description, read-only. And for the input, on the number input. Contract access. Great. The link to the OpenSea NFT, we will add it below the elements in the form, so below the name, the description, and the quantity. So over here we will show only if we have a contract address, because actually we need the contract address to be able to compose that URL. So if we have a contract address, we will create here, let's create a box with the same padding as the previous element, so 2. And then inside a box we will put a link. Yes, a link. So it will be a shaker link. And that link will have href to https OpenSea.io /assets / contract address / the ID of that token. And the ID of the token is just the index. That's why we pass the index, right? So this is the default. Well, we need to put something on the link, inside the link. So that will be view on OpenSea. And we can even put external icon. Some margin. Oh yeah, margin. We need some margin so to separate it. Okay, so this is the production or the mainnet OpenSea URL. Now this URL changes to test nets in the case of using a testnet like Rinkeby. So in here, this portion here, it has to be calculated. So if testnet, then we can put testnets dot, otherwise do not. And that's the link. So we have a link to view on OpenSea, and that link is only going to be shown if we have a contract address. With all these UI elements in place, we can now proceed to the main page, our index page, and in that index page, we will do the mint. Remember that in the handle mint function, we are only uploading the files and then just showing an alert. So today we will finish this function over here. So one of the first things that we need to do is to import the contract. Remember, we imported the contract from the Hard Hat project. So this is the ABI interface. This is the binary interface of the contract. Part of this JSON file is also the bytecode of the contract. So we need this if we want to make a deployment directly from the UI. So the first thing that we need to do in this case is to import the contract. So for that, let's do import MintNFT contract from MintNFT. So now we have the contract, and we need several new state in that index page. The first state that we will use is we will create a state for the contract address. So contract address set contract address. So that initially will be no. Another thing that we need, so we have the contract. We will get a contract address at the end of the mint process. But to actually run the transaction, we will need the signer. So there is a hook we're going to make it that will give you the signer, and that hook is use signer. We need to import it. The signer, as you can see, you can find the signature of that. Returns a state and then a promise, a function that returns a promise with the signer. And I don't care much about the state, but I care about the function. So I will destructure that function. So let's call it get signer. Remember, this is a promise, so we need to await for that promise. It's an asynchronous, basically an asynchronous function. So we need a signer because this is the person that will actually sign the transaction so we can deploy the contract. The other thing that we need is the network that we are going to use. So that we use the hook, use network from, we're going to make it as well. To start the mint process, I think we need to make some basic check-ins. For example, how many elements do we have in the collection? So we shouldn't allow a mint that doesn't have any elements. That will be a waste because basically we're minting a contract that doesn't have any tokens inside. This is unusable. So let's make a first check. So if elements length is 0, then we can show a message, an error message. So we use a toast for that. Toast, and the toast will say, well, no NFT to mint. This is basically GitHub Copilot doing the job, right? Pretty similar to what I was about to write. Please handle this one NFT is an error. I don't think an error is fine. I think an info will be good enough. Toast, we can do a title as well. Info. So actually, we have a title already. Now NFT to mint. Please add at least one. Duration 5 seconds is closable true. And let's put the position on top so it's easier to read. Top. Great. So no NFTs, no mint. Now the second check that we will do is to check if we have a signer, right? So let's check for the signer. Remember, the signer is basically the user that connected the wallet. So if we don't connect a wallet, this signer will be undefined. So if no signer, then we can return a toast. And we will say no signer, please connect to a wallet, error, this will be an error, duration, possible true, position top. By the way, all this code was auto-generated by GitHub Pilot. I guess it's basically, doing some AI on the code that I'm just writing. So it's making assumptions of what I want to write. It's pretty cool, by the way. And we can say, well, everything goes well. Now we have our NFTs. We have the signer. And so we need to set the progress. Let's put the progress in 0. So we initialize everything in 0. We upload the files. So this part is correct. Upload files. This part is perfect the way it is. And after we upload the files, we have to mint the NFTs. And for that, we need to get the contract. The first thing that we'll do when we're minting NFTs is to get a contract. For that, let's go mint NFT. And for that, we will use ethers. So there is a contract factory in ethers. That we can use, and let's import this contract factory from ethers actually, and the parameters will be, well, the MintNFT contract API, the MintNFT contract bytecode, and the signer. So this is our contract, like the instance of the contract. After that, we will deploy the NFT. So let's do await. Actually, the address will be a URL. So remember, the first parameter in our MintNFT contract was the IPFS address, or, well, for the matter, any address. We can use IPFS or HTTPS. In our case, we were using IPFS. I tried IPFS before. I think OpenSea was a little bit slow with IPFS, so I will use an alternative. So we will use the IPFS.io IPFS variant, and so we will put there the response data CID. Remember that this CID is the IPFS ID of where we store the NFT's metadata, right? And because it's a folder, because we store more than one, and we put each NFT in a file named NFT dash the token ID. So it will be NFT dash. So that will be the URL that we are going to pass to our contract. Now, also, we need to specify the quantities, because that's the other part of our contract. We need to specify how many NFTs, how many tokens for each NFT. Remember, if it's only one token, that means that you have an NFT. If you have more than one, it's probably a token, right? So it's fungible. So here we do elements.map. For each element, I will keep the element quantity. And these are the two parameters of our MintNFT contract. You can check the last episode. In that last episode, we create this contract, and the parameters for this the parameters for the deployment of this contract are the URL where the tokens or the NFT metadata is, in this case IPFS, and the second parameter will be an array of all the quantities. So if we send an array of two integers, we will get an NFT with a contract with two NFTs, and each NFT will have that amount of tokens. So that's the deploy. Of course, we need to await that is deployed. And once it's deployed, well, we can inform the user, hey, congrats. So we can say, well, success, right? Description, NFT were minted. Let's put some more description. Your NFT collection was minted. And we can say how many elements dot when NFTs. Of course, we need to make this string template. The status will be success. Duration 5 seconds. Closable true and position top. Okay. And once we send the message, the other thing that we need to set is the contract address. So we need to set the contract address to nft.address. That will set the address. And that's all. Now, if we have an error, of course, we will show the error. And in the finally, we will set, well, it's minted full, progress, back, and that's it. Now, we still have some errors here, and it's because the top bar, of course, is expecting new properties. In the case of the top bar now is expecting the contract address if we had it. So contract address, and it also is expecting a new function for the on new collection. We haven't created this function yet, so this function will be handle new collection. And let's create this function real quick. This function will just reset the whole state, right? To reset the whole state, we say, well, set elements to empty. We set the contract address to null, and just in case, we set the is minted to false. That will reset the state of the application. That's for the top bar. Now the NFT element also needs to, we need to provide more data to the NFT element. One of the data that we need to provide is the index. Locally, we already have it. And we also have to provide if we are minting on a testnet. So And how do we check that? Well, if you have the network data, um, network data, so we had a network data, we should have a chain property. And if we have the chain property, then we will have a Boolean property for testnet. So that will give us a value of true if we are running on a testnet. And the other thing that we need to add here is the contract address. So contract address, contract address. One more thing that we have to limit in this interface is the possibility to add new NFTs once the contract is deployed. So we will show this add NFT button only if we don't have the contract address. And we also, let's separate this a little bit, this button, because it was, from what I remember, it was really close to the rest of the interface. So let's do margin Y. Let's give it a 30 pixel space. We need to import this. Yes. Now we are ready to deploy our first NFT collection. So let's go to the interface. Let's try first the state errors, right? So no NFTs. We get that no NFT to mint. Please add at least one. So let's add a couple of them. I will add the images. And let me put some description. So this is Chicago Heights. Chicago from the top of the Willis Tower. And the second one will be Chicago Theater. Chicago. So we have two NFTs that we will create in this collection, and let's try to mint. Now you notice that I don't have a wallet connected yet, so I actually get an error because of this. Exactly. No signer. Please connect to a wallet. Let's connect to a wallet. MetaMask. And here we are. Now it says that we're going to mint it on wagmi network. By the way, this is the network that OpenSea uses for testing. So that's the one that we're going to be using. First step in the API is just uploading the files to NFT storage. Remember, using our API. And the second step is to confirm this transaction. So we have to be sure that we're in the right network, and we confirm the transaction. As soon as the transaction is confirmed, meaning the contract is deployed, we will get the contract address, and our interface says, success, your NFT collection was minted with 2 NFTs. Now, as you can see, the text on the top changed. Now it says NFT collection minted. We have a button to basically reset the whole application. And for each NFTs, as you can see, you can read the information. You can no longer modify it, right? And you have these new links, the view on OpenSea link. So let's try to open this NFT on OpenLink. And here we are. Chicago Heights. This is the image. It's owned by me because I was the one that basically minted this NFT. We have the description here. And there you go. That's all information. Token ID 0. This is the contract address on the blockchain. And you can see we have more items in this collection. So let's see the full collection. So the full collection has 2 items, 1 owner course, it doesn't have any for price or volume traded yet because it's just minted, recently minted. And there you go. All the NFTs in this collection. On OpenSea, once you have the collection, you can pretty much modify the data from the collection. You have this button here. It will allow you to modify the image of the collection, the feature image, a banner. You can change the name. You can change even the URL to make it more accessible for users. Description. You can add the Twitter, Discord, Instagram, and you see you can pretty much modify all the elements that you want in this collection. But that's something that you have to do on OpenSea. It's not. It has nothing to do with the smart contract. Smart contract only. The smart only handles the tokens itself, right? Well, that will be all for this episode. With this, basically, we have our full app, MintNFT. Remember, this app is built with Nextjs, TypeScript, Chakra for the UI. We are going to make it. It's amazing ReactHook libraries for Web3. In terms of the smart contract, we use Solidity, and we use the hard hat set of tools to be able to build and compile and test our smart contracts. The smart contract that we created was based on the ERC 1155 token. And well, that will be all for tonight. In next series, we will be building new apps. I have a couple of ideas for apps that I want to build using Web3 tools, and we will probably use the same set of the same stack. That'll be all. If you have any questions, the code for the project will be on the description on GitHub, as long as also the code for the smart contract. So you can copy from there. If you have any questions, hit me on Twitter. My Twitter handle is on the description of the video as well. So happy coding.